Standing beside the survey marker at Lake of the Woods, nothing in the landscape suggests that a border exists at all. The water flows around granite islands, spruce branches bend over the shoreline, and the horizon stretches out unbroken in every direction. It looks like a wilderness without divisions, complete and self-contained. Then you check the coordinates. A straight line, negotiated in an ocean-facing room in London in 1818, cuts directly through this water, splitting the continent along the 49th parallel. What is remarkable is not that four men drew a mathematical line across 2,000 kilometers of territory they had never seen, but that for more than 50 years, nobody actually knew where that line fell on the ground. The boundary existed on paper, while the land beneath it remained an unmapped space of shifting shorelines, deeply frozen soil, and ancient human trails. How much of the geography we take for granted is still just a line drawn over a landscape we have barely begun to understand? Under the terms of the 1818 Convention, British and American diplomats sought a clean, simple boundary to separate their holdings from the Lake of the Woods to the Rocky Mountains. The 49th parallel was chosen for its mathematical simplicity. It was a line of latitude, easily calculated on a globe, requiring no knowledge of local topography, river basins, or mountain passes. In the context of early 19th century diplomacy, this abstraction was entirely reasonable. Mapping the interior of North America was an expensive, dangerous, and multi-year undertaking. Negotiating a coordinate was fast, cheap, and gave both empires a frame for future expansion. Where the assumption broke down was on the ground. When the International Boundary Commission finally set out in the early 1870s to mark the prairie section of the 49th parallel, survey crews encountered terrain that defied the neat geometry of their maps. They chopped transit lines through dense forest, waded across expansive wetlands, and dragged heavy iron monuments across open plains. But their mandate was strictly limited: find the parallel, drive the post, and keep moving. They were not there to study the land or catalog its history. A stone alignment 50 meters beyond the survey corridor, an ancient beach ridge stranded high above a modern lake, or a buried living floor concealed under thick muskeg had no bearing on their mission. They marked the boundary line, but the vast spaces between those iron monuments remained as unexamined as before. That gap between official cartography and physical reality persists across Canada today. On modern screens, the country appears fully measured and settled. Its 10 provinces and 3 territories are neatly shaded. Its national parks are outlined in green. Its rivers, highways, and municipal boundaries sit layered in digital databases. Yet these maps represent a thin surface layer. Canada covers nearly 8.8 million square kilometers of land area, but according to the 2021 census, its average population density is just over 4 people per square kilometer. Nearly 3/4 of all Canadians live within census metropolitan areas, concentrated in a narrow band along the southern border. This concentration of population and infrastructure has created a profound bias in the official record. Huge swathes of the northern interior, the Canadian Shield, and the Arctic archipelago see virtually no routine ground survey. The British Columbia Association of Professional Archaeologists estimates that the vast majority of the province has never been systematically surveyed for cultural or historical sites. By contrast, Alberta has recorded more than 40,000 sites. This discrepancy does not mean one region possesses a richer human past than another. It demonstrates that the documented record is almost entirely a product of where highways, pipelines, urban development, and funded research projects have forced investigators to look. Canada has no centralized national agency tasked with systematically mapping the country's hidden physical and historical features. Research occurs sporadically, triggered by a resource extraction project, an infrastructure corridor, a severe erosion event, or a chance discovery. Consequently, the official map is a patchwork of dense data around cities and resource projects, surrounded by vast spaces where our understanding relies on 19th century reconnaissance or high-altitude aerial photography. When we speak of forgotten or unexplained phenomena in this landscape, the term requires precise definition. It does not imply the supernatural or the unexplainable. In the context of field geology and survey history, an anomaly simply means a feature whose age, origin, or extent has not been reconciled with the surrounding record. A site may be known to local residents for generations, but remain absent from provincial databases. A geological structure may be cataloged on a map sheet but never dated. An ancient shoreline may sit submerged under 40 meters of lake water, invisible until specialized equipment is towed across it. The mystery in these places does not stem from a lack of human presence. Indigenous First Nations, Inuit, and Métis peoples have navigated, named, and inhabited these landscapes for thousands of years. What was thin was never human knowledge, but the official imperial and state record, the published survey report, the provincial register, the scientific paper, or the instrument capable of resolving what lies hidden beneath ice, forest canopy, or deep water. As modern technology begins to penetrate these blank spaces, it is revealing that the Canadian map is far from complete. From ancient drive lanes lying submerged beneath the Great Lakes, to ice patches in the southern Yukon yielding organic tools thousands of years old, the landscape is releasing evidence that fundamentally alters our understanding of the past. Yet this shift comes with a sharp time limit. The very environmental changes making the North more accessible are simultaneously destroying the frozen and coastal archives before researchers can record them. The map may look finished on paper, but the real investigation on the ground is only beginning. To understand why so much of the physical and historical archive remains obscured, one must look at the geological mechanisms that formed the Canadian landmass. Millions of years of glacial movement, tectonic shifts, and fluctuating water levels systematically reshuffled the surface. During the last glacial maximum, approximately 20,000 years ago, the Laurentide ice sheet stretched across nearly the entire continent, reaching thicknesses of up to 4 kilometers over parts of the Canadian Shield. As this massive weight pressed down, it depressed the Earth's crust by hundreds of meters. When the climate warmed and the ice sheet began its retreat around 12,000 years ago, it released billions of tons of meltwater, carving deep river valleys, sculpting vast eskers, and filling giant proglacial lakes such as Lake Agassiz and Lake Algonquin. At the same time, the crust beneath began to rebound, a slow process known as post-glacial isostatic adjustment that continues today at rates of up to 1 centimeter per year around Hudson Bay. This shifting ground altered drainage basins, drowned older coastlines, and stranded ancient marine beaches high inland on forested hillsides. Along the Beaufort Sea coastline in the Northwest Territories, this same melting dynamics now operates in reverse. In the Mackenzie Delta region, near sites like Kukpak and Nuvugak, permafrost-rich soil that once held organic remains frozen for millennia is thawing rapidly. Archaeologist Max Friesen of the University of Toronto has spent years documenting how coastal erosion, now averaging roughly 5 meters per year along parts of the Beaufort coast, is stripping away irreplaceable Inuvialuit settlements. At Nuvugak, where naturalist John Richardson recorded 17 winter houses and a large communal structure during Sir John Franklin's second Arctic expedition in 1826, coastal retreat has already washed the visible archaeological record directly into the ocean. In Olivik National Park Reserve on Banks Island, 24 out of 48 known archaeological sites are currently rated at high risk from coastal erosion and thaw slumps. A single severe Arctic storm can strip away up to 20 meters of shoreline in a matter of hours. When frozen silt and peat thaw, the structural integrity of the ground collapses. Organic materials like wood, bone, hide, and baleen, which survive thousands of years in deep freeze conditions, rot within a single warm field season once exposed to oxygen and bacteria. The archive held at the Canadian Museum of History in Gatineau, comprising over 140,000 recovered items, represents only a tiny fraction of what was originally preserved in the frozen earth. Further south, in the alpine interior of the southern Yukon, a different glacial mechanism operates as a natural freezer. Ice patches, static accumulations of snow and ice situated in high-altitude shade, have preserved organic hunting technology across millennia. Led by senior projects archaeologist Greg Hare, the Yukon Government Ice Patch Program has recovered over 200 cultural objects and roughly 1,700 organic animal remains from 43 ice patches. The oldest confirmed artifact, a wooden dart shaft, dates back approximately 9,000 years. The ice patch record documents a clear technological evolution across thousands of years of indigenous land use. Darts launched with throwers, or atlatls, appear continuously from roughly 8,360 years ago down to 1,200 years ago. At that point, dart technology disappears from the ice patches, replaced entirely by arrows, marking the precise era when regional First Nations adopted bow and arrow technology. 6 Yukon First Nations, including the Carcross/Tagish, Kwanlin-Dun, Ta'an-Kwachan, Champagne and Aishihik, Kluane, and Teslin Tlingit, have partnered in this research to map their ancestral territories. In August 1999, 3 sheep hunters in Tatshenshini-Alsek Provincial Park, northwestern British Columbia, discovered the frozen remains of a young man now known as Kwade Dan Sinchi, meaning long ago person found. Radiocarbon dating performed by Canadian research labs established that he lived between 300 and 550 years ago, prior to European contact in the region. Isotopic analysis revealed he consumed a marine-rich diet for most of his life before shifting to terrestrial food sources in his final months, tracing a migration path from the coastal fjords into the high mountain interior. Genetic analysis identified 17 living descendants within the Champagne and Aishihik First Nations sharing his maternal lineage. Cold earth and high-altitude ice act as effective storage systems, but they are far from stable. As rising temperatures melt alpine ice and thaw coastal tundra, ancient records are being exposed and destroyed faster than field teams can reach them. How do researchers find these fragile remains before the environment dissolves them entirely? For generations, the main obstacle to mapping Canada's physical past was not a lack of curiosity, but a limitation of instruments. Standard ground surveys and high-altitude photography capture only what sits directly on the surface.
When features are drowned beneath deep water, buried under thick forest canopy, or sealed beneath tundra, they remain invisible to the eye. The moment of discovery in modern geography rarely happens when someone stumbles across an object by chance. It happens when a new sensor, a revised bathymetric model, or an airborne scanning method allows researchers to reevaluate landscape features that were previously overlooked. Under sea and lake surfaces, submerged landscapes have long been obscured by water and sediment. Beginning around 2008, a research team led by John O'Shea, curator of Great Lakes archaeology at the University of Michigan, began systematically mapping the Alpena Amberley Ridge, a submerged limestone land bridge that once connected Michigan to the Ontario shoreline near Point Clark, across what is now Lake Huron. During the early Holocene, approximately 9,000 years ago, when lake levels sat much lower, this ridge stood above water, creating a natural corridor that guided migrating caribou herds. Using side-scan sonar and remotely operated underwater vehicles equipped with high-definition video cameras, O'Shea's team scanned the lake floor at depths of 37 meters. What they identified was an organized network of stone structures built by early hunters to intercept migrating animals. The most complex feature, designated Drop 45 Drive Lane, consists of 2 parallel, converging lines of stones forming a narrow funnel that leads directly toward hunting blinds constructed from stacked limestone cobbles. Adjacent to the blind sits a rectangular arrangement of stones, interpreted as a potential storage or processing feature. Diver surveys along the ridge subsequently recovered worked chert flakes directly from the sediment adjacent to these stone blinds, confirming human activity on what was once dry ground. While the confirmed Drop 45 site lies on the western side of the international border in American waters, the Alpena Amberley Ridge extends continuously east directly toward Point Clark on the Canadian side of Lake Huron. The Ontario sector of the ridge remains largely unmapped by high-resolution acoustic instruments, pointing to an extensive submerged landscape along the Canadian shoreline that has yet to be surveyed. A complementary dynamic operates along the Pacific coast of British Columbia, where the position of ancient coastlines changed in the opposite direction due to complex sea level histories. In 2018, a research team led by Duncan McLaren of the Hakai Institute and the University of Victoria published findings in the journal PLOS One, describing 29 preserved human footprints on Calvert Island, situated off British Columbia's central coast. The footprints, belonging to 2 adults and 1 child walking barefoot, were discovered embedded in a paleosol layer buried underneath modern beach sands. Radiocarbon analysis of preserved plant macrofossils and charcoal within the footprint layer established an age of approximately 13,000 calibrated years before present. When those footprints were left in the soil, local sea levels sat between 2 and 3 meters lower than modern tides. The discovery added physical weight to the kelp highway hypothesis, which proposes that early human populations expanded along the Pacific Rim by exploiting rich maritime and kelp forest ecosystems, rather than moving strictly through an interior, ice-free corridor. Further inland along the coast, near Quadra Island, post-glacial crustal rebound lifted ancient sea margins far above the modern ocean. By combining airborne LiDAR laser scanning with detailed digital elevation models, researchers reconstructed ancient sea levels that reached up to 200 meters above present water lines, approximately 14,300 years ago. High above the modern shoreline, on steep, forested ridges that no conventional survey would have evaluated for maritime sites, LiDAR revealed elevated paleo-shorelines with high archaeological potential. LiDAR technology has proved equally transformative beneath thick forest canopies, where ground visibility is near zero. In a Secwepemc cultural heritage study, published in March 2025, the Williams Lake First Nation, collaborating with the Zatchul First Nation and the geospatial firm Inlilawat, deployed airborne laser scanning across the Chilcotin region of British Columbia. The laser pulses penetrated the dense forest cover to create a high-resolution digital terrain model, uncovering 70 documented archaeological sites in its first phase, including 31 pre-contact Secwepemc village settlements. According to Whitney Spearing, Natural Resources Director for the Williams Lake First Nation, several house pit depressions detected by the sensor date back over 4,000 years. While oral traditions had maintained the presence of extensive settlements beyond the 4 primary villages recorded in early 20th century ethnographic studies, LiDAR provided the spatial data needed to verify the true scale of habitation. Across British Columbia, remote sensing, underwater acoustic mapping, and radiocarbon dating are systematically replacing old assumptions about where human history can sit. But what happens when the physical evidence being mapped is not a buried structure, but a misread geological claim? Disentangling factual survey data from sensational exaggerations is critical to understanding how Canada's physical history is managed today. The Great Lakes native copper tradition offers a clear demonstration of how inflated claims can obscure genuine human achievement. Along the shores and islands of Lake Superior, including Michipicoten Island and Mamaines Point on the Canadian side, and Isle Royale on the American side, Indigenous groups developed one of the world's oldest cold-hammered copper traditions. In 2021, a study led by geologist David Pompani of Kansas State University reanalyzed radiocarbon dates linked to old copper complex artifacts across the western Great Lakes Basin. Their findings established that native copper extraction and tool fabrication began thousands of years earlier than previously assumed, with a small, conical projectile point from Eagle Lake, Wisconsin, dating back approximately 8,500 years. On Isle Royale, over 1,000 ancient extraction pits have been catalogued, some penetrating up to 9 meters into copper-bearing basalt using stone hammers and fire-setting techniques. However, during the mid-20th century, this documented history was overshadowed by a widely circulated hypothesis initiated by Roy Dreyer and Octave du Temple in 1961, and later popularized by writer Henrietta Mertz. They claimed that an astronomical quantity of copper, estimated without field verification at hundreds of thousands of tons, had been systematically mined and shipped across the Atlantic by Bronze Age European traders. In her 1999 study, Wonderful Power, archaeologist Susan Martin of Michigan Technological University systematically traced these claims to their source, demonstrating that the massive tonnage figures were derived from unsupported estimates stacked upon one another. Martin characterized the transatlantic trade theory as a statement of faith unsupported by physical evidence. Geological and archaeological surveys across the basin show no evidence of European metallurgy or transoceanic contact from that era. Instead, chemical analysis and provenance mapping confirm that Great Lakes copper was extracted by indigenous miners and circulated across North America through continent-wide exchange networks extending as far south as Louisiana and as far west as Wyoming, over a period of 7,000 years. On the Canadian shore, surface copper at Mamaines Point and Michipicoten Island was recorded on French maps as early as 1647. For Anishinaabe communities, including the Michipicoten First Nation, these copper deposits are associated with Mishipeshu,
the powerful underwater spirit. The physical presence of the metal and its cultural significance existed in parallel long before colonial mining companies attempted commercial extraction in the 19th century. A similar distortion occurred with human osteological records in Ontario. During the 19th century, newspapers in Cayuga and Dunnville published sensational reports describing giant human skeletons measuring up to 2.7 meters in height, excavated from local mounds. In 1934, Ales Hrdlička, curator of physical anthropology at the Smithsonian Institution, published a thorough debunking of North American giant skeleton claims, attributing them to exaggerated newspaper reporting, amateur misidentification of extinct Pleistocene megafauna bones, such as mastodons, and deliberate hoaxes. Subsequent archival reviews by modern researchers have confirmed that no physical or institutional evidence exists to support claims of giant human remains in the Grand River Valley or elsewhere in Canada. What does exist in the physical record are actual Ice Age giants. In 1991, workers at a gypsum quarry in Milford, Nova Scotia, accidentally uncovered the near-complete skeletons of an adult and a juvenile mastodon preserved inside an ancient sinkhole. Documented by curator Tim Fedak and researchers at the Nova Scotia Museum under the project title Age of the Mastodon, these animals stood 3 meters tall at the shoulder. Discoveries like Milford explain how massive, fossilized limb bones, when unearthed by 19th century farming or quarrying operations, were easily misidentified by observers who lacked formal anatomical training. These misreadings underline a recurring challenge for present-day land management, distinguishing verified archaeological and paleontological sites from sensational legends, while ensuring that physical evidence is preserved before modern development or natural erosion destroys it. When an industrial project, highway extension, or coastal storm disturbs the ground, who holds the responsibility for determining what sits beneath? This fundamental gap in authority between who held the ground and who wrote the map explains why so many physical features remained uncatalogued by government institutions for so long. The clearest modern example of this institutional blindness is the discovery of Sir John Franklin's lost ships, HMS Erebus and HMS Terror, which vanished during their 1845 expedition in search of the Northwest Passage. For over a century and a half, search expeditions sent by the British Admiralty and later organized by Southern researchers operated on the assumption that European naval records, barometric logs, and theoretical ice drift models provided the only reliable coordinates. Yet 19th century Inuit testimony, gathered by searchers like Charles Francis Hall and David Woodman, consistently pointed to specific locations further south. Local Inuit described starving men walking along the coast of King William Island and reported seeing a ship crushed in the ice near Utchulik, while another drifted south toward Victoria Strait. For generations, Southern institutions treated these oral accounts as imprecise or unreliable. It was only when modern search efforts led by Parks Canada, the Royal Canadian Geographical Society, and local Inuktitut speakers systematically integrated Inuit oral history with high-resolution multibeam sonar that the wrecks were located. HMS Erebus was discovered in 2014 in Wilmot and Crampton Bay, in just 11 meters of water, precisely where Inuit reports had placed a sunken ship. 2 years later, in 2016, HMS Terror was found in Terror Bay off King William Island, resting intact in 24 meters of water. During the 2019 field season alone, underwater archaeologists recovered over 350 artifacts from Erebus, including preserved organic items saved by cold Arctic waters. The discovery of the Franklin wrecks was not a victory for theoretical cartography. It was a demonstration that local knowledge held the correct coordinates all along, while official survey institutions spent 160 years searching the wrong map sheets. What kept these anomalies hidden for so long was not their depth, their remote locations, or their physical complexity. It was the institutional habit of treating land as unmapped until an official survey crew placed a marker on it, ignoring the deep continuity of indigenous occupation that had already named, traveled, and understood every valley, river mouth, and ice patch across the continent. A significant portion of Canada's physical past remains unresolved. Along the eroding coastlines of the Beaufort Sea, archaeological sites containing organic inuvialuit artifacts are sliding into the water before field teams can log their positions. In the southern Yukon,
High-altitude ice patches continue to thaw, releasing 9,000-year-old wooden shafts that deteriorate within seasons if left exposed. In the Great Lakes, thousands of kilometers of submerged paleo-shorelines remain unmapped by high-resolution sonar. The official map of Canada appears complete on our screens, polished and settled within fixed borders. The ground beneath it is nowhere near finished. Which landscape feature or historical anomaly in your own province or territory has always seemed misread or overlooked to you? Let me know in the comments below, and consider subscribing to follow our ongoing investigations into the hidden geography of North America.